Hi there, welcome to the lab. Today we're going to have a look at this rebranded Smart Digital Multimeter. This meter comes to me through the Amazon Vine program, and this is apparently labeled as Amtovl. We'll see what's inside in a minute. I'd just like to say that if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Questions and comments are always very welcome. Feedback is appreciated, and it helps me figure out where to focus my activity. Now, without further messing about, let's get in the box. This has got a fancy open tab on it. It comes open, and there's a nice little internal case, nothing else in the box. Zippered pouch. Open that up. We've got a set of probes. We'll have a look at that in a minute. There's a charging cord, so this is a rechargeable meter. And then there are a set of alligator clips. We'll have a look at that a little more in a minute. And a temperature probe. The meter itself, so that's a full screen. Oh, I see that's Amtovl, not Amtovl. No. And I guess one of the first things I'll have to do is charge that up. And then there's a manual here. The manual is in many languages. And so in case you were wondering, this is about 14 pages for each language, 14 pages for English. It's got English, German, French, Spanish, and Italian. Okay. Amtovl. Okay. Now the probes, I don't think this is definitely not silicone. These are fairly stiff, and there are some shrouds that come off easily. These look to be nickel-plated probes, so nothing unusual there. And the connections are straight, although that looks a little curved, if you will. So they're not right angle connectors, although that one looks like it's had a little bit of issue in the heat molding process. And then these alligator clips, they slip on to the ends. I'm sure you've seen a lot of units like this. And so they slip on like so, and then you've got alligator clips on the probes, and so that's handy. I have a few of these for my other probes. Nothing to worry about there. We'll have to charge this. And then this is a standard thermocouple, K-type thermocouple. Nothing unusual there for measuring temperature. But I guess it does tell us that the unit measures temperature. So what I'm going to do is I'm going to plug this in and get it charged up, and then we will put it through its paces. To charge this, I have to take off this rubber overmold in order to access the USB port. I'm sure you didn't want to see me struggling with this protector, and so the USB charge port is over there. And so plug that in. The good news is it charges with a USB power delivery cable and not just with this USB-A to USB-C cable, which I'm not very fond of. And I guess if you can make it out here, the charging status is this bar along the bottom. The unit's all charged up. I'll pull off this protector film. Look at that. Very nice new screen. Super. Now I guess to turn it on, we'll use this button here. There we go. That's nice. And so I will say that the display, first impression here, this display is just awesome. That is the nicest display I've ever seen on one of these meters. So from a display point of view, top marks. Except one of the odd things I noticed here, a little bit of a spelling issue. That is not how you spell true. So we've got a meter that does pure RMS. Maybe that was meant to be pure RMS, I'm not sure. Look at what else we have here in terms of basic controls. This button allows us to select various functions, and we can see the function that we're in here. It's got a little gear symbol, so that's ohms. That's now, I guess that's diode. That's frequency, capacitance, temperature, and then that's current. Not sure what that is. That may have, okay, now I'm in AC/DC voltage. I've got some sounds there. I've got a light here. I think I've got a light. Okay, that might be the hold function. Okay, now there's a flashlight. Well, I'm not seeing any light, although it says there's a light. And then we've got live wire non-contact voltage mode. And so if you haven't realized it yet, these are not, these are sort of touch sensitive areas. These aren't even physical buttons here. So we'll kind of get a little more familiar with the operation as we go on with the unit. So that's what that means. When I've got the three dots here, I didn't actually even see this up at the top. I was so focused on what was going on down here. When we've got these three gears here, we're in auto mode. And in auto mode, I guess it can sense between voltage, continuity, and resistance, which is common. That's what this auto mode generally does. But the good news is that we can also put it directly into the voltage mode. Okay, that was DC voltage, then AC voltage, then resistance. And continuity and diode check, I guess, are combined. We'll look at that a little later as well. So interesting way to kind of group the features together, but you know, that's always manufacturer's discretion. No complaint there. I am still trying to figure out how to get this light working. Okay, well that definitely turns the light on, but I can't see it on. Yeah, so that light doesn't seem to work, which is unfortunate. Now, I'm connecting the probes. These are very stiff to insert here, which is kind of okay, but much stiffer, and it's hard to tell whether I've fully inserted them properly. We'll go with that. So we'll start out in auto mode. I'm not generally a fan of auto mode, but I just want to make sure it works as it's supposed to. And so we can see here that these symbols are connected. And so in auto mode, it'll differentiate between AC and DC voltage, continuity, and resistance. Now the calibrator is currently set to output voltage, and right now it's set to 0 volts, but because of the way auto mode works, it's probably going to think that this 0 voltage output is a 0 resistance, and it's a closed circuit as a result. And so yeah, it starts to make a lot of noise. If I bump the voltage up to 1 volt, the noise goes away. It's correctly figured out that it's DC voltage, so that's very good, and that was actually pretty quick. But that is one of the properties of auto mode. You can't necessarily measure all the functions. If we, for example, put out a resistance here, the 20 ohm resistance here, so as a typical, it is showing the 20 ohm resistance or pretty close to it, but at the same time, that's not high enough. It thinks that's a continuity situation. When we go up to 100 ohms, then the buzzer turns off. And so that's more or less working the way we would expect auto mode to work. It's showing for the 100 ohm resistance about 100 ohms. And we'll look at resistance a little more in the dedicated mode. And so the auto mode works like most auto modes, but you do have some of these challenges where sometimes, especially with low voltages, it can't necessarily figure out what's going on. So 1 volt, not a problem, but when we go down to half a volt, that's fine. 4/10 of a volt, 3/10 of a volt, that's fine. 2/10 of a volt. See, now it's kind of like, well, that's not voltage. Now I think it's resistance. And so it's reading that as a resistance as opposed to a voltage. And so that's one of the sort of challenges with auto mode, and one of the reasons why I'm not a huge fan of that. But it works fine for auto mode. Okay, now in DC voltage, after going through many of these cycles, because it's only got this one selection button, you have to sort of tap it repeatedly to advance through the cycles. And so you can't directly access any function. And it can be a little tedious if you don't get the right function. You have to kind of cycle through all of them all over again. Anyways, right now we are in DC current mode. A little bit of noise appearing there because things aren't connected. We'll connect it up to the calibrator. 0 volts, no tone signal to drive us crazy, showing 0 volts very well. We'll go up to 1/10 of a volt there, 0.099. That's pretty good. We'll go up to half a volt. Exactly, dead on, can't complain. 1 volt, dead on, perfect. 5 volts. A little bit of error there, but nothing really too terrible. And then we'll go up to 10 volts. And once again, dead on. So good accuracy, I would say, overall, for the most part, for DC voltage. Now for current, the unit has lit up. It's a little tough to see because of the reflection here, but the unit lights up over here to show that the probe needs to connect in this spot over here. And so we'll connect the probe there. And so that's a different way, a very nice way of showing where to connect probes, since they've got such a great display. And so I've got the calibrator, it's set up, and it's outputting 4 milliamps. We'll connect that. And 4 milliamps is showing A, but nothing before that, so 4 milliamps is terrific. We'll take that to 8 milliamps. Okay, not quite there, didn't settle in. Let's go up to 10. Okay, not quite, and I think this maxes out. Okay, let's try 16, 14, 15. Not going to get to 16. We'll get to 24, which is where the calibrator maxes out. So seems to be off by about 1 milliamp, which is, for a unit like this, pretty good. I'm pretty satisfied with the milliamp readings. There could be a little bit of resistance in the leads that I'm using, causing the discrepancy of 1 milliamp. So nothing to complain about there. Pretty happy with the performance in the milliamp range. Now I've got the units hooked up for AC voltage. I use this Bryman as a comparison reference. It tends to be pretty accurate. Power's not on right now, so there's a little bit of ghost voltage, and we're seeing pretty much the same reading on both units. Let's turn the power on. And it takes a while, but it does come in. It's off by about 0.2 of a volt relative to the Bryman. And it does have, because of this secondary display, it is showing the frequency here. And so we can see it's picking up 60 hertz. And in a unit like the Bryman, which only has a single display, we have to kind of do that and choose to go into the frequency mode in order to see the frequency display. And then back to the voltage. Now let's try one more time just to get the response speed. Okay, so now they're both showing the ghost voltage. Power on. And a fairly noticeable amount of lag in order to get the reading. And when the reading comes up, like I say, it varies between 0.2 and 0.3 of a volt in terms of difference relative to the Bryman. Looking at AC current now, I've got a little AC fan here. I've got the Bryman as our reference meter and the Amtovl as the meter we're interested in. Everything is wired up so that these kind of all flow through each other in a series fashion. And now I'm going to turn on the power, and we'll see initially as it powers up, we've got a little bit of a higher current draw, and as the fan begins to settle into its operational speed, the Amtovl is showing 165, sometimes 166 milliamps, and the Bryman is also showing more or less 166, 165 milliamps. So very good performance here on the Amtovl in the AC current range. Now for resistance, I've got the unit into the ohms mode, resistance. The calibrator is set up. It's not connected yet. 20.1. And because this is not auto mode or continuity mode, the low resistance reading is not causing the tone to sound, which is terrific, just the way we want it to work. We'll take that up to 100 ohms. Once again, a tiny little bit of error in the unit. We'll take it up to 500. And you can see that there's a bar graph at the top here now that I hadn't noticed before. And that's showing 500. So, and it goes to 60. So this must be based around a 6,000 count model. We'll go to 1K. And you see it flash a little overrange thing for a second as it switches out, figures out ranges. So 1K. We're a little low here for 1K, about 2 ohms off. Let's go up to 1500. Okay, much closer reading there. Now we'll go up to 2K, 1.99. That's pretty much right on. So very good readings there. Very kind of happy. This, I think, maxes out at 2200 ohms. So 2.199. Pretty much dead on as far as I'm concerned. Happy with the performance in resistance. Now we're going to look at frequency. That's been an issue with some of the meters. So right now, nothing is connected. It's showing 0 hertz. That's kind of what I would expect. I'm going to connect the common on the calibrator. And so now it's showing 60 hertz, which is a little bit of a puzzle because the calibrator is outputting 100 hertz and not 60 hertz. Let's plug in the red line. And so it's not picking up that 100 hertz signal that the calibrator is putting out. So that's 1 kilohertz, and it's not picking that up either. So the calibrator puts out a pretty solid 50% duty cycle square wave that I've analyzed before, because I do tend to have a lot of trouble with these meters in frequency measurement. And so this one is not really behaving the way I would expect. Another look at frequency, this time I'm using the AC power line as a frequency source. And so it is now, everything's kind of connected. The power is not on, but it can pick the frequency up through the ghost voltage. And you can see it's showing about 60 hertz there. When I turn the power on, it gets a little bit better, 60 kind of dead even. And that's what we have here as the frequency. So with the sine wave coming out of the mains, that seems to work pretty well. It's just this can't really handle, I guess, the square wave that the calibrator puts out. Now for temperature, the unit shows temperature all the time based on an internal sensor, but it does take temperature inputs as well. And so I've got this hooked up. The calibrator can simulate a K-type thermocouple, and for these purposes, anything within 2 degrees Celsius is fine. Now, so I'm going to hook this up. So that's showing 0, and that's showing 0 as well, so that's perfect. We'll take that up to 100 Celsius. Perfect. 200. 500. So perfect, and it's showing the in this sort of secondary display area, it's showing the Fahrenheit equivalent for the temperature. So that's very nice. And so temperature sensing is fantastic. Nothing to complain about there. Now we'll have a look at continuity. I've installed the default probes, and as I mentioned, it is tough to get the probes in, but it works. And if I tap these together, you can see the response on the display, but doesn't respond very quickly. It could be the probes, but it does take a while. So let's try that with a set of gold-tipped probes instead. I've connected a pair of gold-tipped probes, and we can see the display responds pretty quickly. So much faster response than with the probes that came with the unit. So, as is pretty common, the gold-tipped probes make a huge difference, but it still does have a little bit of lag that is noticeable on the continuity. So it works just fine, especially it works fine with the gold-tipped probes, but a little bit of lag that I'm not too fond of. Now we're going to look at Diode Check, and I've left the gold-tipped probes in because of how frustrating it is to get the probes into this unit. So let's try this out. We've got the good reading on that diode, no tone. Good reading on that one. Lights up that one, that one, that one, that one, that one. And of course continuity just fine. So it works just fine, lights up all the diodes, but it doesn't have the sort of short tone for the sort of functional forward biased diodes that I like to hear. Now for capacitance, I have this reference board, and we're just going to go through these things one at a time, and I'll call these out. Make sure my hands are not in the way so you can see everything. So that's 100 picofarads, and it doesn't seem to be reading that at all. This is 1 nanofarad, and that's a little low. 10 nanofarads. Once again, a little low. 100 nanofarads. A little low again. This is 1,000 nanofarads. And a little low. And 10 microfarads. And it's a little high, but fairly typical for what I see when I'm testing out this particular capacitor. So pretty good performance on the capacitance, except generally reading a little low compared to the reference values, and not able to pick up at all the 100 picofarad capacitor. Now for testing non-contact voltage, I'm just going to put it into non-contact voltage mode. So that's now, that EF says it's in non-contact voltage mode. I have this plug and the hot line is along this edge, and we'll just bring that close to the top of the unit. You can see at about 1 centimeter it starts to respond, and as I bring it right against the unit, sensing very strongly, and then we can see the sensor is more or less centered at the top of the unit. So good performance for the non-contact voltage detection. Now for live wire detection, we press this again, and that shows live, and we plug this in here, the red line. Okay, and I've got the same plug again. So this is the hot side, ground neutral. We'll take the probe and we'll put it in the neutral. No response there. And we'll put it in the ground. No response there. That's what we expect. We'll put it in the hot line, and no response there either. Not what we expect. Now I'm going to hold this. One of the things I found, if I touch the unit, it does respond. And if I let go of the unit, it stops responding. Now if I take the common line and connect it, although it doesn't indicate here that I have to have the common connected, but I connected the common anyways, and we come back to the plug like that. Ground, that's what we expect. And now it does sense the hot line. And so you can see that there's sort of an antenna effect of having the common line connected that shouldn't be required according to the instructions. But I have seen that in a few systems, or a few of these meters, where there is some sensitivity around the live wire detection, and just having the sensing line on its own, if we unplug that, just having the sensing line on its own doesn't seem to work as expected. A bit of a teardown now, and so I've taken the screws out of the 4 corners, and this flips up, and we can see the this must be a lithium polymer battery here, and it's got some wires that run in there, and they're soldered onto the main board. Now, in some sense, there's a lot to see on this unit, and in some sense, there's not a lot to see on this unit because the identifying marks have been removed from most of these chips, and so we kind of have to do a little bit of guesswork. So let's start down at the bottom here. So the buttons have, each button has an individual LED here. So the buttons are lit up using their own LEDs here at the bottom. And then we can see here, there actually, let's make sure that stays in focus. There actually is a 10 amp fuse here. So there's a fuse there, but it's soldered in, and I guess that's great. So we can replace it if we absolutely have to. There's a PTC down here. And what else can we see? This is some flash memory. So this will have some calibration configuration information. There are a bunch of pads here. I think that's maybe one serial line. There's another set of pads here, maybe another serial connection or some other data connection. Now I think this chip, although the identification is removed, I think this is probably the LCD driver. It kind of has the same form factor as most LCD drivers. This one I expect is the main sort of multimeter control circuitry, and that's in this one. Now what's interesting is that there's another SMD chip here that's in a kind of similar form factor, and it's really unusual to see 2 of these. So I think this is probably a microcontroller of some sort that they're using to kind of manage the whole unit. And I think that's one of the reasons why there tends to be so much lag in a lot of the functions, because it's kind of got to do a lot more, or a little more anyways, calculation than typical. We've got the speaker here. there's a relay here. Now the relay, you'll see these in the multimeters that have fully soft switching. So when there's a mechanical switch, the electrical path to the sensing elements on the DMM chip is switched with the mechanical switch. But when you have a soft switch like this unit has, then this relay is used to switch the input connections as required into the appropriate inputs on the DMM chip, because the inputs used for I think for voltage and resistance and stuff like that, and there's probably different inputs that are used for current. And so anyhow, the switching is done via this relay. And the one thing which was a little bit odd, well, you can see there's a few places where there is some spots for other chips that are not here. There's a spot here. There's kind of a spot here, although it's kind of a little bit weird because you'd expect to see another set of contacts up there, but whatever. And then there's an LED here, but it's only visible internally. It's not visible outside of the unit, so it's a little bit odd. Now, I did find, while I had it open, it was a little more obvious. When I turned the flashlight on, this does light up momentarily, so it's not a bad connection, but it doesn't stay lit. So the flashlight functionality is still, let's say, non-functional. And that's more or less all there is really to see here. This is a beautiful meter that covers all the features that are common in a modern multimeter these days. Unfortunately, there are several shortcomings that suggest that this meter might not be quite ready for prime time. I keep mentioning the display because that really is one of the standout elements of this meter. It's also nice that it has a rechargeable battery, and all the basic electrical measurements work well. On the other hand, the flashlight doesn't seem to work at all. The probes are difficult to insert and remove, and the overmold, which I haven't even put back on yet, covers the charge port at the side here. Square wave frequency measurement doesn't work, and live wire detection doesn't work correctly. While the other measurements work fine, there is a general sluggishness to the unit where it takes a noticeable amount of time for readings to settle in. I would love to give this unit a thumbs up because of the fresh design with the excellent display, but I can't. Most people using a multimeter are far more interested in accurate operation. If you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Thanks for watching, and until next time.